All right, good morning, everyone, and thank you very much for your invitation at the Korea Maritime Week 2021. It's really a pleasure to be the first speaker today. I'm very sad I cannot be there physically. I hope the travel restriction will allow me to come and visit you very soon. I think we have to wait a little bit more. We have to be patient. The last time I was with you, that was for the Maritime Week 2017. That was just at the end of the revision of the G8 guideline, the transformation into the code. And we discussed about type approval testing, the robustness of the testing, what it means in terms of compliance and so on. Today we'll focus on commissioning, the biological commissioning test after installation of the system, and which is basically to become the first step of the survey and certification, meaning ship owners will receive, or the ship will receive, an international ballast water management certificate after the successful commissioning test. I expect port state control testing will come because the convention has a biological standard, which is the objective of the convention itself. So eventually this will come. It's still a bit of a challenge because it's different from what port state control officers do on their day-to-day basis. But eventually I'm confident that that will come at some point in the near future. The commissioning itself is a normal process. The ship owners have invested and are investing a lot of money in buying equipment which treat the water down to the D2 standards. They want to make sure the equipment functions. In reality, the commissioning test goes much beyond the evaluation of the functioning of the system itself. When we do the commissioning test, we are verifying that the 3D planning have been done properly, the installation in the yard has been done properly, the crew has been trained properly, the ship has been prepared properly, meaning cleaning of the tanks, making sure the valves are not leaking, and so on and so on. So for us, a testing organization, we are the last player in that picture, and we are the only one who have not been involved whatsoever at any point in the preparation of the ship with the treatment system. And that's why the independency of the testing organization is crucial here in order to make sure that the verification is done in a proper way. It's particularly important, to my opinion, in that this commissioning test may be the only verification that we are going to do in the life of a ship, that the ship can discharge water with limited amount of organism in its entire lifetime, so over 20 years. If there is no port state control testing, we will never have any idea, if we don't do the commissioning test properly, whether the ship or whether the convention actually is working as a whole. So this is very important actually as a test. Initially, it was approved in MEPC 73. It required 2 samples, one untreated sample and then one sample after treatment, for the simple reason that if you find 0 organism after treatment, it doesn't mean that the system works. If there were 0 organism in inlet, then we still don't know whether the system is working or not. So that was a bit of the origin of the 2 samples here. Indicative analysis for all parameters, and including system design limitation, which has been a challenge initially, because until last October, some of the treatment system installed on board were systems that were approved under the old G8 guidelines, and for which it was not mandatory to define system design limitation. Luckily, this is not a problem anymore. During MEPC 75, the IMO has refreshed basically the circular 70. 2 samples may still be needed, but only 1 is required, and that are necessarily the discharged. Indicative analysis still is a rule. 10 to 50 micrometer and more than 50 micrometer only need to be assessed. There's no more need to do the testing for the microbiology. Overall, removing the inlet water has not saved time because we still need to wait for the holding time, meaning the time between the inlet and the discharge, the time that is necessary to kill the organism on board the vessel, so the time the treatment needs to treat the water. So we have not saved time on this step. We have only lost actually information. But there is a saving of time by removing the microbiology, because initially the microbiology could not be done with indicative analysis. All these analyses that were done required incubations, and that took some time. There is now a method that has been approved in the revision of the Circular 42, and which allowed testing in a very short amount of time, but that was removed at the same time from the Circular 70, so no big deal here. From 2022 June, all the new installation will have to go through that test. Luckily, today, there are already some early implementers of this regulation, and we need to be very thankful to them, because thanks to the fact that they have requested that test on board the vessels sailing the flag, we have learned a lot in the last 1.5 years, and you will see in my next slides that this early implementation actually is going to support everyone in the industry. So there are more and more flags who have requested this early implementation. Initially, there was only Singapore from September 2019, and ever since we have had support from Tuvalu, France, Australia, Croatia, Cyprus, technically all the European Union. The last one joining the team here of the early implementers being Liberia. India is not a party of the convention, but already require commissioning on the vessels. Overall, things are getting better, more and more knowledge and the preparation from the vessel. So at the yard, the 3D designer and so are getting much better. So basically we are seeing less and less failures. There are 3 classification societies requiring an approval of the service provider carrying out the test. They want to make sure that the service provider is fully independent from the yard, fully independent from the 3D designers, installers, and so on. And they want to make sure that the test is done according to what IMO can do best. We are very supportive of this accreditation. It costs money, but we think this is actually the right way to go. And it's the right way to go at least until the ISO 11711, which is the international standard, which is developed for sampling and analysis of ballast water sample. Until that standard is finished, we need to have at least that approval of service provider. We are very supportive of that. The ISO 11711, it's a request from IMO, from MEPC to the ISO committee to develop a standard that can be implemented globally. It can be done and put under accreditation of laboratories doing the testing, and that's accreditation 17025. So that bring a level of quality assurance and quality control here, which is extremely important in that case. So what is quality testing? Quality testing is not simple. It requires a good, I would say, biological understanding of what is sampling and analyzing, but it requires to understand what the regulation says, and it requires that you understand what are the regulations. There are a lot of information on sampling and analyzing in the IMO documentation, but it's not all in one place. So you have information from example, in the guideline G2 that gives you information on isokinetic sampling, how you design a sampling port, and so on. But it's an old guidelines that probably will deserve to be revised at some point. The code, the G8, the revised G8, has been going through a round of revision with a lot of inclusion of knowledge and expertise from the testing organization, which makes it much more robust than the previous one, and which is a little bit more updated than the G2 guidelines. We're talking about 3 cubic meters for the volume. We're talking about sampling, the sample holding time. So how much time do you have after you took the sample to analyze the water? The Circular 70 for the commissioning requires analysis of at least 1 cubic meter. But in reality, if you do an indicative analysis and it fails, you still need another cubic meter to do the detailed analysis. Therefore, you need at least 2 cubic meters. There is no reference in the Circular 70 that one can do detailed analysis. This exists in the port state control guidelines. So technically, we have to do indicative analysis first. And if it fails, the class authorized to use detailed analysis as a step that basically prevail over the result from the indicative testing. It's a bit challenging here. It would be very nice that the detailed analysis is fully included in the Circular 70 at some point. The method that can be used are listed in Circular 42 revision 2. As I said, now we have included microbiology testing capabilities for indicative analysis in a rapid way, but they have been removed from the Circular 70. There is also another paper which is not listed here, which is a Circular 61, which refer to the MPN methods for the 10 to 50 micrometer size class that has been used by some testing facility during type approval. But this testing requires regrowth for 14, 15 days. And so the delay on the report should be expected if you are using this method. So the expertise from the testing organization is crucial. And for sure, the most important part here is really independency from the installer, the 3D designer, the manufacturers, the ship, and so on, the yard. And so to make sure that we can evaluate without issue whether the test is correct or not. I will add ISO 17025, but that doesn't exist in every single country. So there is one regroupment of organizations that actually assure quality of testing, assure comparable and accurate results, and that's the Global Testnet. So the Global Testnet has been developed under the umbrella of the GlobalAS program, so the IMO run project that was funded by GEF and through UNDP. Global Testnet has been doing thousands of tests all together globally. And prior to the enforcement of the Circular 70, they had already stating that detailed analysis should prevail and should be used when possible. So if there is possibility to use detailed analysis, we should do so. You are lucky in Korea. 4 of the Global Testnet members have operation in Korea. So you are, I think, the countries with the highest concentration of Global Testnet members globally. For us in SGS, we have been in supporting the shipping industry and the maritime industry in general since 150 years. We started in this industry. We are offering a consistent testing for all the compliance monitoring program, for environmental testing, for the Marine Labor Convention, and so on, in 330 ports around the world, supported by a network of laboratories and surveyors. When it comes to the D2 testing, the commissioning testing, we are supporting government and ship owners in doing the test. And we are doing that in a consistent manner across our organization. So we are using the same sampling equipment, the same method, same SOP, same training, same reports, and so on. So far, just for the commissioning, we have been carrying out 560 tests, 28 different manufacturers, which is very interesting. All the systems are very different. So it's interesting for us and we learn a lot. It's probably very challenging for the crew when they change ship to actually have to deal with a system that functions differently. And the interface for running the system from one to the other are very different. There is no consistency here, so it's probably very challenging for the crew as well. We have been doing tests in 22 different countries, and this is still increasing on a regular basis, basically 1 or 2 countries extra every month. It's not, I would say, a luck or by magic that we have been able to deploy such a big capabilities very fast over the last 1.5 years. It's because in SGS, we have had a training facility for sampling and analyzing ballast water since 2013. And for the last 8 years, we have been training on a yearly basis teams from all over the world in our facility in Italy. And so when I, as a regional manager, jump from one country to another, I always meet someone that has gone through that training. So I have already a basis in every country of people who know what ballast water is, know how to sample ballast water, know how to analyze ballast water. And so this is really, really supporting the fast implementation of the testing capability globally. Now we have a sampling equipment that has been developed with BSH, the German administration, as early as 2012 or 13, that has been benchmarked against other sampling approaches. It can work closed loop, meaning the water can technically be flushed back into the discharge line if the sampling port have been designed for that. And we have the capacity to insert a probe using a hot port if they exist on board the vessel. And that's basically what you have on the image here at our training facility. You can insert and remove the probe. And we have put a small glass screen here to show our trainees basically where the probe is and ensuring that the isokinetic sampling is actually carried out. This equipment has been used already for Australian government, Singapore government, and so for the administration as part of the experience building phase. It's very useful. So when the 3D planners and the yards are struggling to install the piece and bits of the treatment system to have a workable installation, sometimes we end up with a sampling probe that is squeezed in very remote area, difficult to access. Because we have a sampler which is made for that, we actually can do this kind of test. It can be a little bit challenging as well from the testing side. We talk about the volume, 3 cubic meters in the code, 1 cubic meter for each of the analysis under the commissioning test, meaning 2 cubic meter at least if you do detail and analysis. The nice paper from Miller et al. In 2011 refers to 7-8 cubic meters, and this is basically what has been used in the Korean testing facility for the type approval over the years, and that's probably the right way to go. Sometimes it's difficult to sample even 1 cubic meter because on very small system, the discharge pipe is very small, the sampling probe is very small, and when we have sampling probe at 1 centimeter big, it's very difficult to sample 1 cubic meter in an hour. So there is a trade-off here between volume and isokinetic sampling, which is impossible to solve at that stage. As I said, the G2 gives information. The small picture on the right here explains how the G2 probe should be designed with a probe facing the flow in length at least one of the diameter of the probe. The 11.7.11 standards from ISO will give a way more information on where to install the probe and how should the piping be done actually, which will help a lot. And we are talking about laminar flow, and we are talking about whether the water is going upward or downward. So if the water is in a vertical pipe, the water should go up, which is a problem in all the installation on deck house, for example. That cannot be an isokinetic sampling in that case. There is a very nice paper from Lisa Drake and co-authors from last year, which is basically a plea for standardization of the sampling port to help the commissioning, but also to help the port state control and to do compliance monitoring and enforcement, which is crucial for the success of the convention. On the left, the hot port, basically to be able to insert and remove the sampling probe, we see only 5% of the global installation actually installed with hot port, where we can use external probe. The real key to success actually is, aside from the sampling probe and isokinetic sampling, is really the preparation. So preparation of the crew, training is important, and preparation of the ship. So cleaning the tank is really a step that should not be missed. Most of the failure we have observed come from dirty tanks. We give information to our clients on how clean should be. And if you look at the small cups on the bottom left here, this is really something we do on vessels when we want to explain that to the crew and the class and so on. This is untreated water on the left, the clear water. And after the water has gone through the ballast water tank and is discharged through the discharge line, we take a sample, the water sample on the right here, you see the murky water. This is what's coming out of the tank. And that clarifies very quickly the tanks need to be cleaned. It has been a bit of a learning curve for everyone here, but now we know tanks must be very clean to avoid contaminations. Now, the great point about the data we have generated here is a trend. And in 2020, when we published that white paper on the commissioning test, we had more than 20% failure rate on the commissioning, which looks dramatic. I want you to look at carefully on the graph on the top left corner here. We started at more than 20% failure. We are down to 5 or 6% failure, and that's very low. And by the way, even when there is failure, after investigation, after you find out where the failure come from, you fix the issue, and things are working. The ship is going to when we do the retest, the ship is actually capable of discharging water that meet the D2 standards. So the convention, the standard, even if it's a stringent, very stringent standards, it's working. The equipment, the installation can be done in a way that things are going to work. So on that aspect, at least we should feel confident. Now we have one problem with the TRO. TRO is not regulated by any of the standard of the convention. It's actually evaluated by GESAM during basic and final approval of the treatment system. But during the commissioning test, we are requested to make let's say a calibration verification. So we verify that the reading from the treatment system is actually the same as we can read as an external independent testing organization. And we can see a lot of discrepancies here. So we may have a challenge that needs to be looked into with the irregular discharge of compliant TRO water somehow. All the failure we have observed on a size class more than 50 micrometer. So the big bugs, the big organisms are actually the most robust one, and they are the one we find in the water. The organism in the 10 to 50 micrometer size class have never been a problem so far in the testing that we have been doing. I think we have only one experience where we find some, and the system was just not working at all. Microbiology, it depends, but it's not a big rate of failure, a couple of % only. Most of the failure, more than 90%, is with the organism more than 50 micrometer. They are the one difficult to sample, but they are the most important one here for the compliance monitoring. So things are working overall. We still have a challenge with the TRO sensors. We need to keep an eye on. Actually, it's not only the TRO sensors, it's all the sensors on the equipment. They need to be calibrated or at least verified on a regular basis. The owners with who we have been talking have been complaining a lot that there is a monopoly of who can do this testing today, which are basically the technology developer. But technology developers are not present in every port in the world, which is a challenge for ship owner when they want to access to someone to verify the calibrations. But these, for now, are the rules under the code. We will see over time whether when ships are going through challenging water and are using contingency measures, whether that potential contamination is going to impact accumulation of organism, regrowth in the tanks, and so on. For this, we don't have much feedback. A couple of papers from Singapore, Canada, Australia on the commissioning, on the compliance monitoring data that have been sent to the experience building phase information, with a very interesting paper from Canada lately, where I see the first proposition eventually to start evaluating or monitoring compliance outside port state control regime. That means annual test, for example, like the VGP, which would be possible and could support an evaluation of whether the convention is working without putting too much pressure on the ship owner during port operations. I think the real key here to the success is really the ballast water management plan, because it's not only about having a compliance system or an approved system on board the vessel, is really understanding what we are trying to do with ballast water management. And that is crucial. So training of the crew is really a key here. And we need to give the crew systems that are relatively easy to use, relatively easy to maintain, and a ballast water management plan, which is developed to help the crew to actually get it right from the beginning. And that's my small input for today. And I'm looking forward to a nice discussion now. Thank you very much.